Okay, we're now into Chapter 3, and in Chapter 3 we're going to be looking at exponential functions. We start with the idea of a basic exponential function, which is in the form a times b to the x. The key is for an function to be exponential, the variable needs to be in the exponent. Okay, we need to have a base that is positive. Okay, b is the base of an exponential term, remember that. It needs to be positive and it can't be 1, because 1 to any power would simply remain 1 and it would be a linear function. Our a, our coefficient of b to the x, needs to not be 0, obviously, otherwise it's the function y equals 0, which again is the linear function. So here we have this basic form of our exponential function. There's a couple key things. If we are looking for an initial value when x is 0, we recognize that anything to the 0 is 1, and this whole thing simplifies to just a. And so a tells us the initial value of the function. Okay, and then b is the base, like we talk about anytime we're talking about exponential terms. So here we have a couple just basic exponential functions. First of all, we have to decide state. If they are exponential functions, and if they are, we need to state the initial value and the base. If they're not, we need to explain why not. So looking at our first function, we have a to the x. Okay? X is in the exponent. That makes it an exponential function. Looking at b, we have x to a power. That's our power function. That is not our exponential function because x is not in the exponent. So this is not a exponential function. In fact, it's a power function. Okay, if we check all the rest of them, we have x in the exponent, and that's really the key piece that you need to have an exponential function. So the only one that is not an exponential is b. So here we have an exponential function. We need to identify the initial value, and we need to identify the base. Okay, I'm going to start actually backwards. I'm going to start with the base. Base is what's being raised to the power x, and so if we look at that, we have 8 as our base. Initial value can be memorized as the a, but technically any initial value is always the value you have for the function when you put 0 in for x. A to the 0 is 1. C, again, it is an exponential function, so we need our initial value and we need our base. Again, I'm going to start with the base. Base is what's being raised to the power x, so it's 6.5 to the x. Initial value, if I put 0 in for x, we get 6.5 to the 0, which is 1. And 1 times negative 3 is negative 3. Okay, continuing on here in D, initial value and base. I do want to look at that base again first. Here we have 2 to the negative x. When we're looking for the base, we want to know what is being raised to the power x. And so we need to take care of that and rewrite this so that we don't have a negative x as our exponent. So one way we can start by doing is writing this as 2 to the negative 1 to the x, remembering that when we have power to a power, we multiply our exponents. So negative 1 times x gives me that exponent of negative x. And so 2 to the negative 1, that's a reciprocal, so we have 1/2 to the x. And so all that work tells us that our base is 1/2. Okay, now back to the initial value, putting 0 in, 2 to the 0, 0, times 3 is 3. Okay? And the last one, why don't you pause this right now, and I want you to try and see if you get the idea of what the initial value and base is. Okay, once you've got that done, go ahead and come back and try it and check it with me. Okay, so you should have this already done. The initial value is 2. The base, again, is a little bit more complicated than straightforward. We have 3 to the 2x. We need to write it as something to the x. So we need to separate it and make it 3 squared to the x. Multiplying those exponents would give me that 2x. And so that means my base is 3 squared, or my base is actually 9. Okay? So keep in mind that when you are looking at your exponential function, it is a base to a simple power of just x. To figure out what that base is, sometimes we have to do a little bit of work. Okay? All right, continuing on, we have working with exponential functions. And we're working just with finding values. We have 3 to the x as our function. We want to find the value for the function at these particular x values. Okay, nothing extremely complicated, simply substitute your value in for x and find the value of the function. So the first one we're finding f of 3 if we want to go to function notation. And so we're doing 3 to the 3rd power. And so we get 27. Okay, for b, why don't you try b and c? Do those two for a moment. Pause again. You try. Okay, hopefully you have those. We should have 3 to the 0 here, which is 1. And 3 to the negative 2. We've been reviewing a little bit of the negative exponents already. That means I have 1 over 3 squared, which means I have 1/9. Okay, now let's do d and e together. We have exponents that are fractions. We have 3 to the 1/4 for the value of the function when we have x is 1/4. What does that mean? Do you remember what a rational exponent means? Okay, hopefully you'll recall that the denominator tells you the type of root you're working with and the numerator tells you the type of exponent. So 1/4 means I have a 4th root. So this is the 4th root of 3. Okay? If we want to give an approximate value, we can put that in our calculator. We can find the 4th root, but I wouldn't do it with a root. If I'm working with my calculator, I would actually type in 3 to the 1/4 since that's a much quicker way to type that in. It's on our main screen as opposed to having to go to the menus to get that. Why don't you try it on your calculator? Make sure you know how to find 3 to the 1/4. Okay, hopefully you've tried that again. Pause if you're still working on it. Okay, if you do, you get 1.32 as an approximate value for that root. Then we have a combination. We have a negative and a rational exponent. So we have 3 to the negative 3/4. Okay, first of all, it's negative. So that means I have the reciprocal, 1 over 3 to the 3/4. Okay, then we have the idea of a rational exponent. I'm going to separate it for a minute so you can see what's going on. We could think of 3 to the 3/4 as 3 to the 3rd to the 1/4. Multiplying those exponents would give me 3/4. It helps you to separate because I know a lot of you have understood the idea of 1/4 being the 4th root. But with there being the 3 in the numerator, I want you to recognize that that gives you the exponent actually on the 3 that's going to be applied within our radical. So this simplifies to the 4th root of 3 cubed. Or, one way to write that is the 4th root of 27, 3 cubed. Again, we can find that value in our calculator. When I would put that into my calculator, I would actually use this form, or actually go back to the original. Put it in as 3 to the power negative 3/4. Okay, as we do that, we would get an approximate value. Why don't you try it again? Make sure you know how to do it. Pause it for a moment and try that. Okay, if everything went well, you get 0.438 as your approximate value. Sorry, off the screen on that one a little bit. 0.438. Okay. So just a reminder of how to work with radicals, or how to work with your rational exponents. Putting them in an exponential form is much easier on your calculator to work with. Okay, let's do one more and then I'll pause this video and go on to another one. Okay, the last thing we're going to do is find an exponential function. We have 2 lists of values here. We have 2 functions. We have a g function and an h function. So we're going to find those individually. I'm going to do the g one with you and then let you take a moment and do your h function. So we're going to find g of x. We're told it's exponential. So we know it can be written in the form a times b to the x. So you need to find this specific exponential function. We'll leave that space for the h function in a moment. To do this, it's often most helpful to really start by working with your initial value. Okay, we're going to start here. Knowing the initial value gives us some key information right away. So we're going to put those values in. When x is 0, the function's value is 3. So 3 for the value of the function, 0 for x. Okay, what is b to the 0? Okay, hopefully you recall that anything to the 0 is 1. So this really tells me that a is 3. We already know our a value, so we're all getting close to what we need. We need our a and we need our b. So far we have the function written as 3 times some base to the x. We want to figure out what that base needs to be. It makes it easiest to work with our smallest and our nicest values of x. So after I've done my initial value, I'm going to go ahead and go next to working with a value of an x value of 1. Okay, using that next piece of information, when x is 1, the function's value is 6. So 6 equals 3 times b to the first. Putting 1 in for x. So b to the first is just b. Solving for b, I divide both sides by 3 and I get 2 for my b. And so my function for this particular set of values for g is 3 times 2 to the x. Okay? Pause the video. Right now I want you to try that again on your own. Try doing that with your values for h. See if you can find the function that represents those values, the exponential function. Okay, hopefully you did. If all went well, here's what we have. H of x is an exponential function, so a times b to the x. Working with the initial value, you should find that a is 2. Remember, initial value is when x is 0. So we have 0, 2 for your initial value for h of x. Okay, then solving, working to find b, that's using your next set of values. You should get that b is 1/3. So you can write your exponential function out as 2 times 1/3 to the x. Now there's another way to write that works out just as nicely and can be written the same or have the same values. We could write this as h of x equals 2 times 3 to the negative x. Okay, either one of those would be acceptable for an exponential function. Just need to recognize that if you have the negative x there, the base is technically 1/3. Okay, I'm going to stop the video here and you'll have to go on to the next one for the next page.